Okay, in this video I'm going to talk a little bit about spreadsheets and data analysis, and as we're doing this, this is a spreadsheet is a powerful tool that you can use for kind of taking data and doing stuff with it. And so I'm going to show you some things that I'm going to kind of show you some techniques here, and I'm not going to show you everything, but I'm going to show you stuff that we need for what we're doing right now. And your goal should be not just to be able to do it right now, but also to take away some of these things for future activities. So here I've got some data I entered, and this is actually different data than you use. So when I graph it and stuff, it's going to look different. Okay, but the analysis will still be the same. Okay, so before I graph this data, I want to get a column for velocity and for acceleration. So if you remember, velocity is the slope of your position graph. And so what we're going to do is, since we don't have a function for position, we're going to find average velocities of little segments. Because while that's not the same thing as the instantaneous velocity, since these chunks of times are very small, it's going to approximate that instantaneous velocity. Okay. And so the way we do that is just find the slope between the 2 points. So we can't start here because we don't have points there to use. So we're going to start right here. And we use the equal sign. So anytime I do a calculation, I start by typing the equal sign. And then in parentheses, I'm going to say this value minus the previous value. Okay. And then I'm going to divide that by this time minus the previous time. Okay, this is the slope formula. Change in x over change in time. Average velocity. Okay, and there you go. We get a value for average velocity. Notice you get something different if you leave out these parentheses on accident. Okay, make sure we include, actually for this one you don't, but for those you would. Okay, make sure you include those parentheses. So like if I do it right here, but I leave out the parentheses right here, and right here I get something different. Okay, so gotta include those. So what you can do though, once you enter that formula, you only have to type it in that one time, and then Excel actually pastes the relationships for those cells if you click and drag that little blue box. I'm going to paste it all the way down, apply it to my whole table. Okay, and it's just pasted that formula down. Okay. Alright, and so you can see that the only thing is changing. I can click on it, see for each one what's being used in the calculation. Okay, and then for acceleration, we do the same thing since acceleration is the slope of velocity. Okay, and I can even paste it over and then make some changes because instead of using, I want to use row A instead of row B. I don't want to use position, I want to use time. Okay. And I've jumped down another row because this is, again, I don't know what the velocity was there. Okay, and again, I'll drag this down. And I'm pretty sure there's a command you can do to fill it down, but I don't remember what it is. Okay, and you're going to notice that there's a lot of variation here. It's jumping from -5 to 1 to -0.4 to 2 to 3 to -4. Okay, and just know that acceleration is the change in the changing position, and so it's going to cause a significant amount of variation. Okay, now since I don't have values for acceleration here or here, when I go to paste this into Desmos to analyze it, I'm going to skip the first 2 lines. So I'm going to select all this, I'm going to go ahead and copy it, and I'll paste it into Desmos. Gone ahead and pasted my data in. You can see what a mess this acceleration data is. So just to make this easier to look at, we can even click here so we don't see it on the graph. Okay, so here's our position data, here's our velocity data. Again, yours are going to look different. And so before I get started though, I want to format this table so it represents what these quantities are. So this was t. Okay, so it says t1, this was position, so we'll say x. This was velocity, so we'll say v. and this was acceleration, so we'll say A. Okay, now we can use the Desmos to actually generate equations for these lines. Okay, Desmos does regression. It does beyond linear regression. I can create like a quadratic fit and stuff. And so basically what I'm going to do is I'm going to type in my equation for position. So x equals v naught, or we're going to say at squared plus v naught t plus x naught. Okay, now remember that v naught, or a here, is actually not a because it's 1/2 a in this position equation. But everything else is kind of here how it goes. Now, this is the equation for position, but we want to kind of take this format and use it with the data in our table. And so what we're going to do is we're going to connect things to the table. The first thing we do, though, before we do that, when we're doing best fit lines, we change the equal sign into like this little squiggly, and that's how we tell Desmos we're doing a best fit line, so that it's going to calculate line for us. So this is x1. We're going to make this t1 there and there. And so you see this equation I have now for this line, and you can see here this value for a. So a should be twice that value. So 0.088 would be maybe like 0.176 or something like that. So negative 0.176 would be my acceleration here. It tells me what my initial velocity was, okay, and it tells me what my starting position was, and so you can kind of gauge to see how accurate those ones are. Okay, you're going to do one of these also for v. Okay, but instead of using position function, we're going to use velocity function. And then finally for a, we're going to use the mean function, because we just want to take the average, right? We don't need to do a best fit line because the acceleration is not constant, but it's hopefully constant. You can see it's all over the place, but we take the average, and you're going to notice this average is pretty close to twice that amount. So if I take this and double it, let's see. Let's do that real quick. We're going to say 2 times that. 0.1769. I got pretty close here with 0.173. Okay. So anyway, you're going to basically find acceleration 3 different ways. Okay. And so these are 3 different tools we have. So one is using just our position data. One is we found this using our position data, we found average velocity data and made gonna make a linear equation for velocity, and then using that velocity data, we found acceleration and found that average acceleration. Okay, so hopefully we'll see how close these values come out. You know, I tried it once and they were pretty different but fairly close, and then here's an example where they are, at least these two are pretty close. Okay, and your goal is to use this with the data to see the rate at which gravity causes things to accelerate. See how close we can get to that and see where we get as a class. Okay.